Our lesson for today is all about solving problems involving sides and angles of a polygon. So what are the things that we need to remember? The word polygon is a Greek word poly, means many, and gon means angle. A polygon is a flat or plane figure, two-dimensional closed shape with straight sides, and it does not have curved sides. The angles formed by the sides of a polygon are called interior angles of a polygon. The angle formed where its sides are extended are called exterior angles of a polygon. Next, the sum of the interior angles of a convex polygon with n sides is given by s is equal to n minus 2 times 180 degrees. The sum of the exterior angles of a convex polygon, one at each vertex, is 360 degrees. The measure of each interior angle of a regular polygon represented as r is equal to n minus 2 times 180 degrees divided by n, which is the side of a polygon. Next, a regular polygon is an equiangular or equal angles and equilateral or equal sides polygon. And last, the interior angle and its adjacent exterior angle form a linear pair. It means that the sum of their measures is 180 degrees. Let's proceed. Kathy received a regular hexagonal jewelry storage from her mom as a Christmas gift. If its perimeter is 120 centimeters, what is the measure of each side of the said storage? To solve this problem, let us answer the following question. First, what is our goal? Second, what are we going to do? And third, what is the measure of each side of the hexagonal storage? And last, what does your answer mean? We should follow a systematic procedure in solving problems such as the Polya's problem-solving techniques, which highlight the following steps in solving the given problem. So for our step 1, let's understand the problem. In the given problem, our goal is to solve for the measure of each side of the hexagonal storage given the perimeter of 120 centimeters. Step 2, let's devise a plan. The perimeter of a hexagonal storage is the sum of the measure of its 6 sides. And since the perimeter is given, we need to divide it to 6 to find the measure of each side. Now for our step 3, carry out plan. Now, let us solve this problem. Here's our solution. So let P is our perimeter of the regular polygon and S is the measure of each side. So, let's apply first the formula. Our formula now is P is equal to 6S. Using the substitution, we substitute the value of our perimeter, which is 120 centimeters. So therefore, we have 120 centimeters is equal to 6S. And after that, let's apply the multiplication property of equality by multiplying both sides by 1/6. And after that, we will have 120 over 6 centimeters is equal to 6S over S. So, let's simplify. So we have now 20 centimeters is equal to S, and by applying symmetric property of equality, S is equal to 20 centimeters. For our step 4, let's look back. Since we already know the answer, we can now interpret it. Therefore, each side of the regular hexagonal jewelry storage measures 20 centimeters. Let's solve more problems involving the sides and angles of polygon for better understanding. For our first problem, the rectangular lot measures 15 meters by 11 meters. What is its area? Let us apply Polya's problem solving techniques in solving the given problem. Step 1. In the given problem, our goal is to solve the area of the rectangular lot that measures by 15 meters by 11 meters. For our step 2, to solve this problem, we should put in mind that the area of a rectangle is the product of its length and width. So in symbol, we can denote it as A is equal to LW, or A is equal to L times W. Stands for the length and width. For our step 3, for our solution, let A is the area of the rectangle, L is the length of the rectangle, and W is the width of the rectangle. So let's apply the formula of the area of the rectangle. Next, let's substitute the given. So our length is 15 and our width is 11. So we have A is equal to 15 meters times 11 meters. So let's simplify. 15 meters times 11 meters is 165 square meter. Again, if we're looking for the area, the unit must be square unit. And for our step 4, therefore, the area of the rectangular lot is 165 square meters. Next problem. In their mathematics group activity, Ryan was assigned to measure the exterior angles of a regular octagon. What is the measure of each exterior angle of a regular octagon? Step 1. In the given problem, our goal is to solve for the measure of each exterior angle of a regular octagon. Step 2. The sum of the measure of the exterior angles of any polygon is 360 degrees, and a regular polygon has equal measures of angles and sides. It means that we just need to divide 360 degrees to the number of sides of the regular polygon to determine the measure of each exterior angle. Next, for our step 3, for our solution, let x is the measure of each exterior angle and n is the number of sides of a polygon. So let's apply the formula of the measure of exterior angles, which is x is equal to 360 degrees divided by n. And let's substitute the value of n, which is the number of sides, which is 8, because the given on our problem is octagon. So we have 360 degrees divided by 8. Let's simplify. We have 45 degrees. For our step 4, therefore, the measure of each exterior angle of a regular octagon is 45 degrees. Next problem. Given the figure below, determine the unknown measure of the exterior angle. For our step 1, in the given problem, our goal is to solve for the measure of each exterior angle of the given figure. For our step 2, notice that in the given figure, the interior and exterior angles are considered as linear pair. In other words, they are two angles created along one line when two lines intersect. And since they formed a line, the sum of their measures is always 180 degrees. And for our step 3, for our solution, by the definition of linear pair, 100 degrees plus the degree measure of angle x is equal to 180 degrees. And by the addition property of equality, we have 100 degrees plus the degree measure of angle x plus negative 100 degrees is equal to 180 degrees plus negative 100 degrees. So we can cancel 100 degrees, and for the others, and for the right side, we subtract 180 to 100. So therefore, the degree measure of angle x is 80 degrees if we simplify. So for our step 4, therefore, the degree measure of angle x is 80 degrees. Next problem. Rosa was assigned to measure all the interior angles of heptagon. What is the sum of the measure of all its interior angles? For our step 1, in the given problem, our goal is to solve for the sum of the measures of all the interior angles of a heptagon. For step 2, the sum of all interior angles of a polygon can be solved by solving for the difference between the number of sides of a polygon and 2, then multiplying the result by 180 degrees. Consider that the heptagon is a 7-sided polygon. And for our step 3, for our solution, let S is the sum of the measures of all the interior angles and N is the number of sides of a polygon. So by applying the formula of the sum of the measures of all the interior angles, so S is equal to N minus 2 times 180 degrees. So let's substitute the value of N, which is 7, because the given polygon in our problem is heptagon. So we have 7 minus 2 times 180. We will have now 5 times 180. And after that, let's simplify. 5 times 180, we will have 900 degrees. Therefore, the sum for our step 4, the sum of the measures of all interior angles of heptagon is 900 degrees. Next, for our last problem, given the figure below, determine the sum of the measures of the interior angles and the value of x. For our step 1, in the given problem, our goal is to solve for the sum of the measures of all the interior angles the sum of the measures of all the interior angles of the given figure as well as the degree measure of angle x. For our step 2, in solving the given problem, we need to determine the sum of the measures of all interior angle of the given figure, then use the result in finding the degree measure of angle x. For our step 3, for our solution, let S is the sum of the measures of all interior angles and N is the number of sides of a polygon. So let's apply first the formula for our solution. Let's apply first the formula in finding the measures of all the interior angles to find the sum of all the interior angles. So which is S is equal to N minus 2 times 180 degrees. So let's substitute the value, which is 5, because the given figure in our problem is a pentagon. So we will have S is equal to 5 minus 2 times 180 degrees. After we substitute, let's simplify. So we have now 540 degrees. Since we already know that the sum of the measures of all the interior angles of the pentagon is 540 degrees, we can now solve for the degree measure of angle X. For another solution, the sum of the measures of the interior angles of pentagon is 540 degrees. So, we just have a formula of this. So, 540 degrees is equal to 80 degrees plus 120 degrees plus 90 degrees plus 150 degrees plus the degree measure of angle X. Let's combine the similar terms. So, we will have now 540 degrees is equal to 440 degrees plus the degree measure of angle X. Next, let's apply the addition property of equality by adding both sides by negative 440 degrees. We will have now 100 degrees is equal to degree measure of angle X by simplifying. And next, by symmetric property of equality, the degree measure of angle X is equal to 100 degrees. For our step 4, therefore, the sum of all the interior angles of the pentagon is 540 degrees and the degree measure of angle X is 100 degrees. That is our lesson for today, which is solving problems involving sides and angles of a polygon. Thank you for watching.